The denominator of this algebraic fraction is a product of two linear factors. In this video, let's learn how to obtain the partial fractions of such a fraction. We have learned that two algebraic fractions can be combined to form a single fraction. Now, how about the reverse direction? When given single algebraic fractions, how can we split them into their parts? We call these parts the partial fractions of the single algebraic fraction. Let's now learn more. Here, let's focus on fractions with denominators containing only products of linear factors. Do note that the fraction needs to be proper. That is, the degree of the numerator must be less than the degree of the denominator. Let's start with this one. What partial fractions, when combined, will give us this single fraction? First, we need to know the denominators of the partial fractions. How? Let's revisit these two fractions which combine to form this single fraction. Can you see that the factors of the denominator correspond to the denominators of the partial fractions? Similarly, this single fraction has partial fractions with denominators x minus 1 and x minus 2. Second, we need to find the numerators. Now, if the single fraction is proper, its partial fractions will also be proper. We can see that the denominators have degree 1, so the numerators must have degree 0. That is, they must be constants. Similarly, the numerators here must be constants. Let's call them a and b and find their values by combining the partial fractions into one single fraction. Now, these two fractions are equal. Since they have the same denominator, they will also have the same numerator. We can equate their numerators to find the values of a and b. Do you remember how to solve for a and b? One way is to substitute values of x. So, what x value should we use? To find a, it is useful to eliminate b times x minus 1. So we choose an x value that makes this term equal to 0. So we use x equals 1. Substitute 1 into the equation and simplify. We get a equals 3. Similarly, to find b, it helps to eliminate this term. Choose an x value that makes this term equal to 0, so x equals 2. Substitute 2 into the equation and simplify. We get b equals negative 1. So we can express our single fraction in terms of its partial fractions. Let's look at this next fraction. Its denominator is a product of linear factors. We must also check if it is a proper fraction. Its numerator has degree 0. Its denominator has degree 2, higher than that of the numerator. So this fraction is proper. Now, let's find its partial fractions. First, find the denominators. They should correspond to the factors in the denominator, that is, 2x plus 1 and x minus 2. Second, we need to find the numerators. Remember that these are proper fractions. Since the denominators have degree 1, their numerators will have degree 0, also known as constants a and b. Let's find their values by combining these two fractions into a single fraction. Again, since these two single fractions are equal, and have the same denominator, we can equate the numerators. This time, let's try comparison of coefficients. Do you remember how? To start, expand the right-hand side and group the like terms. Then, compare the constants. So, negative 2a plus b equals 5. Next, compare the terms in x. Observe that the right-hand side has a term in x, but the left-hand side does not. So, a plus 2b equals 0. Solve these equations simultaneously. We get a equals negative 2, b equals 1. Finally, we have our single fraction in terms of these partial fractions. This next fraction seems different. Is it a proper fraction? Yes, it is. However, its denominator is not a product of linear factors. Well, not to worry. All we need to do is factorize it, so the denominator becomes a product of linear factors again. Then just as before, its partial fractions will be of this form. Once again, combine them into a single fraction and equate the numerators. Try finding a and b yourself. You should get a equals half and b equals half. So this fraction is expressed in partial fractions like this. And we can simplify them to this. Finally, let's look at this fraction. This time, it is an improper fraction. So we need to first use long division to express it in terms of proper fractions. But the denominator is still not a product of linear factors, so we need to factorize it to get this. So now we know that this single fraction has partial fractions of this form. Try solving for a and b on your own. You should obtain a equals 1 and b equals 1. So this single fraction is expressed in partial fractions like this. In summary, we have learned how to obtain the partial fractions for this type of algebraic fraction. The partial fractions have denominators corresponding to these factors, and their numerators are constants. To find the constants, combine the right-hand side and then equate the numerators. Take note that if a fraction has a denominator that is not factorized, then that's what we need to do first. We can then find its partial fractions. Finally, if a fraction is improper, we need to express it in terms of proper fractions before proceeding to obtain the partial fractions.